Alright, on day 2 of the shell method, we are going to be talking about rotating it about the x-axis. Now, if I was to do this problem, I would never choose to do the shell method on this because it would create a dy problem. I like to do volumes of revolution using dx's. That's just my choice. Typically, they're always in y equals equation, so it's easier. But because this is me teaching the horizontal axis of revolution with the shell method, I will use the dy problems today. So what this says is we have this volume that we're rotating about the x-axis. You can see that it's a shell because what it's doing is creating those cylinders. The volume formula is v equals 2 pi from a to b of the p of y times h of y dy. So let's go ahead and find what p of y is. P of y is the radius here, so we're talking about going from 0 to y, which would be really a negative y. So it's 0 minus y, which gives you a negative y for your p of y. Our h of y is the height of this rectangle here. Now the problem with this is we're going to go right minus left, so we have 3 minus. We have to have this function in terms of a x equals equation. So I need to do that really quickly. Y minus 1 equals negative x, and so x is equal to 1 minus y. So I'm going to take my 1 minus y and place it inside of there. That's what h of y is. That's the height of that rectangle. So we've got 3 minus 1, which is 2. Let's go ahead and just make that a 2. And then distribute your negative 3, which gives you a plus y. So we end up with negative y plus, or times 2 plus y, dy. And then what we're doing is we're talking about dy, so the change in y, so we're going from negative 2 to 0. Alright, we're going to go ahead and distribute the negative y through, so I get negative 2y minus y squared dy. Integrating gives me negative y squared minus negative y cubed over 3. And I need to plug in the negative 2 to 0. So I end up with the answer of 2 pi times 0. When I plug in 0, I get 0 minus, I've got a negative 2 squared minus a negative 2 cubed over 3. Got tons of negatives going on here, so I'm going to take this slow. I've got a positive 4, which now makes it a negative 4. I've got a negative 8, which now makes it a positive 8 thirds. I have this minus out front that I'll worry about here in a second. So now I end up having a positive 4 plus a negative 8 thirds with the 2 pi out front. This gives me 12 thirds minus 8 thirds times 2 pi. So that's 4 thirds times 2 pi, which gives me the answer of 8 pi over 3. In the second problem, I'm going to rotate about the x-axis again. If you look at the picture, I'm rotating this area or around this plane about the x-axis. Sorry, I couldn't get it out. Now, the one thing you have to be cautious of is if you actually go from negative 4 to 4, you're actually going to have way too much volume. You're going to actually double your volume. So we're really, when we set up this integral, we need to be careful that we only say that it's the volume from 2 pi from 0 to 4 of the p of y, h of y, dy. And it is a dy problem because we are rotating about the x-axis. And if you notice that the base is on the y-axis. So this means I need to solve this for x. So this would be 16 minus y squared. So what I need to do is I need to find my p of y, which is the radius from where you're rotating this to the rectangle. So that would just simply be y. And then the height of this would be the right-hand side minus the left-hand side. So it's this curve. 16 minus y squared minus 0, so it's just simply 16 minus y squared dy. So we'll go ahead and simplify this. I end up getting 16y minus y cubed dy. Go ahead and integrate it, which gives us 16y squared over 2, which would be 8y squared minus y to the 4th over 4 from 0 to 4. So when I plug in my numbers, I end up getting 128 minus 64 minus 0, which is 64 times 2, which is 128 pi. My last example is telling me that I'm going to be rotating about, or this y equals square root of x about the x equals 6 line. All I'm doing is drawing that in really quickly. So it looks something like this. I'm only going from here to 4 though. So only this region is being rotated about the x equals 6 line. So what this is going to do, and I'll try to get through this problem, but I may only get it set up. This is, if I'm going to use a shell method, this is a dx problem because you can see how the base is sitting on the x-axis. So we're going to go from 0 to 4. This is a shell because the cylinders would be created. What I have is my p of x is right here. My p of x would be 6 minus x, so the right minus the left, 6 minus x. And then the height of this rectangle would be this top minus the bottom, or just simply the square root of x minus 0, or the square root of x. So when I go to plug this in, I would have 6 minus x times the square root of x dx. So when I simplify it, I get 6x to the 1/2 minus x to the 3/2 dx. And now I'm ready to integrate it. So I'll raise it by 1 and put it over that power, minus, raise it by that, put it over that power. If you'd like to see the end of this, me plugging in the numbers, I can do that for you during class, but I'm simply not going to have the time on this video. Go ahead and try the numbers and plug them in. You should end up with 192 pi over 5. I can try to see where I get to at this point. I get 2/3 times 6, which would be 12/3 or 4. So I need to change this to be a